Let's talk about high-speed application delivery to cloud. Cloud teams want to deliver applications securely and quickly to AWS, but are struggling with the unending complexity of the AWS security model and feeling frustrated and frankly scared that their data is going to get breached or destroyed. Customers deserve for their data to be secure, and engineers want that data to be secure, deliver quickly, and go home on time. The business wants to go faster. But once we ramp up change throughput, manual security policy breaks down. So does analysis of who has access to what. Despite everyone's best intentions and efforts, we're all afraid of gaps in security policies that put data at risk. Let's talk about an open secret. The usability of AWS security is broken. It's hard to get AWS security right and difficult to validate without deploying and breaking everything or making it insecure. Because it's so difficult, anyone who's a cloud security specialist is overloaded immediately. You don't have time to dig through blog posts, API docs, learning about all the APIs, and spend hours or days tweaking policies only to find you probably missed major threat vectors. Let's face it, the usability of AWS security is broken. This results in project delays, or more commonly, teams defer security until tomorrow. What we need to do is integrate security into your delivery pipelines, leveraging tools you already have. Unlike many security tools, K9 puts usable infrastructure code libraries and actionable information in the hands of cloud and DevOps engineers who build and maintain security policies. First, K9 provides secure infrastructure code libraries for Terraform. You use these to specify your intended access clearly and let K9 take care of generating least privilege security policy and secure resource configurations. Second, K9 lets you audit and report the effective access of each IAM principal whenever you want. The comprehensive and correct access report is simple for everyone to understand and delivered daily. Third, K9 gives you a simple language to describe access so everyone understands what each principal should and actually can do with data and APIs in AWS. You can understand and improve your security continuously with K9, just like anything else. This is real DevSecOps. Let's see how K9's infrastructure automation helps with everyone's data breach nightmare, AWS S3. Consider an application that has a web front end that accepts data and writes it to S3. That data is processed by a separate back-end process. You can imagine that this app processes credit applications. We'll start by understanding what we write. Here, we see a simple declaration of who should have access to data in the sensitive data bucket. The CI user may administer the bucket. The backend role may read data from the bucket. And both the backend and web role can write data to the bucket. So you can imagine the web front-end application accepting, say, credit applications and putting them in the bucket, and then they're processed by some other backend process. When you run Terraform apply, the module generates a bucket policy that implements best practice. This policy is hundreds of lines long. The best practice includes least privilege, encryption, and closing security gaps you may not know or certainly remember. The S3 module is open source and available on GitHub in the K9 Security IO organization. Let's check it out. This module supports managing an entire bucket or just the bucket policy. The S3 module has features needed for regulated secure environments, consistent naming, least privilege bucket policy, strong encryption, tagging, access logging, and more. There's full usage documentation that covers administering access and securing the bucket. The module documents and tests usage of both the bucket and a policy-only use case. Let's look at the bucket. This instantiation of a secure bucket configuration should be a breath of fresh air. Here's a bucket whose name, ownership, and accessibility is declared simply and understandably. Now, if we drill into the examples directory, we can see what kind of policy that simple declaration expands to. Each of the 6 K9 access capabilities become a statement if it applies. So we have statements for administering the bucket resources, reading data, writing data, and deleting data. We also have several deny statements, which are the keys to best practice. This deny everyone else statement is the key to least privilege because it prevents everyone who isn't in the list of allowed principals from accessing the bucket. This defends your data against overprivileged IAM principals, such as a firewall that might have the ability to read all data from S3. There are several more statements in here implementing requirements for encryption in transport and at rest. Best practice? Check, check. Now let's tackle the question, who has access to our data in AWS? The senior cloud, DevOps, and site reliability engineers we've talked to generally respond, that's impossible. And without K9, we agree. It really is very hard because AWS security policies provide so much flexibility. K9 answers this question for you with the access inventory. The access inventory answers from two directions. First, given a principal, what access does it generally have to services like S3, RDS, DynamoDB, IAM? And we also tell you which specific resources the principal has access to, such as a bucket. Second, given a resource such as an S3 bucket, who can access it? This capability lets you really focus on your most critical data and who can access it. This access capability is reported in terms everyone can understand and the same terms engineers use to declare their intended access using K9 infrastructure automation. Read data, write data, administer resource, etc. The resource access inventory is generated daily in both Excel and JSON formats, then delivered to your secure inbox encrypted with your own encryption key. Let's take a quick look at the Excel form of the access report. Most users start by going to the Resource Access Summaries view. You can use this to answer who has access to my most critical data. As you can see, we start with the service, then we list different resources and the access capabilities, and then who has access. In this development account, the reports bucket is the most important resource. So you can toggle the filter, search for reports, and select just the reports bucket. There are several users and roles that have access to the bucket. This access is reported simply, consistently, and correctly. In large accounts, this is very difficult to determine for a single resource, let alone all of them. Many auditors can use this report directly to answer questions about access controls and compliance. Engineers can easily identify unwanted access, and they now have clear data to go improve security policies. Cloud teams improve security and accelerate delivery with our usable automation and audit tools. These are the tools cloud teams need to integrate security into their delivery process and create effective feedback loops that protect data. Let us work with you to accelerate secure change delivery, reduce frustration and failures, reduce risk, and protect customers' data. Book a call with us today at k9security.io/call.